In this video, I'm going to demonstrate a bivariate regression and how to use the regression equation. We're going to use SPSS to calculate the best fitting regression line and the coefficient of determination. You will find this procedure by clicking on Analyze and going down to Regression. And you want to click on Linear because we're going to look at a linear regression. We're using the 2006 GSS, and in this example, we're using the respondent's education to predict the number of hours worked in the last week. So our independent variable is education, and our dependent variable is the number of hours worked in the last week. We want to enter the dependent variable hours 1 in the dependent variable box, and you will see that SPSS always puts the dependent variable first when we do an analysis, and you'll notice that in the syntax as well. And the independent variable is education, and so we will place that in the independent variable box. The independent variable box has space for multiple independent variables. We are just going to use one right now for a bivariate regression, but when you start doing multiple regression models, you will have multiple independent variables in this box. The linear regression dialog box offers many other choices that you can look through, but we are going to stay with the default output for this particular procedure because it's really all that we need. Make sure you paste your syntax and go to your syntax editor and highlight your regression syntax and run it. SPSS produces a lot of output in the output window. You can see there are 4 main boxes. The first one is the variables entered or removed. Then you have your model summary. There's an ANOVA. And finally, at the bottom is the actual regression model. We're going to focus on 2 portions of this particular output. We're going to start by looking at the model summary, and then we're going to look under the coefficients box, where the actual regression model is. Under the model summary box, you can see the coefficient of determination is labeled R² right here. And the value of the R² is 0.009. We might say that this is relatively weak, and educational attainment explains very little of the variation in the number of hours worked in the last week. It's less than 1% because you would multiply this by 100, 0.009, to get the percentage, and that means this independent variable, education, explains 0.9% of the variation on the dependent variable, which is the number of hours worked in the last week. Let's now look at the coefficients box, which is the regression equation. Results. The regression equation coefficients are listed in the column headed B under unstandardized coefficients. So first, the row here is the constant, the very first row where it says the constant, and this is the intercept, 36.331. This is your intercept, or the A term. You interpret 36.331 in the following way. People with 0 years of education are expected to work 36.331 hours in the last week. So this is our intercept, and it's labeled as constant in SPSS. The next row is the highest year of school completed, and this is the independent variable of interest. And you will see here 0.420, this is the slope. This is your B term, 0.420. When we think about how to interpret this number, we would say for every additional year of education, which is our unit on the independent variable, we would expect to see a gain of 0.420 in hours worked in the last week, because this is the unit of the dependent variable. You might want to translate that into something that's a little bit easier to understand, maybe the number of minutes. So your coefficient is 0.420. That's about 25 additional minutes of work each week. It's a gain of 0.420 because it's a positive number. We have a positive slope. So the independent variable goes up and the dependent variable also goes up. You might want to use these numbers in your regression equation and figure out what might happen for someone who has a specific number of years of education. We can solve using the regression equation, y equals a plus bx. And let's go ahead and do that now. I'm going to place it in the syntax editor so you can see what we're doing. If you want to write notes in your syntax editor, remember that you should put an asterisk and then make sure you end it with a period, and SPSS knows it's a note to yourself and not a command. So we're going to use the y equals a plus bx equation. And so we're going to be solving for y. Let's say we want to know about somebody who has 12 years of education. The a is our intercept, and so here that's 36.331. And we're going to add that to our slope multiplied by the number 12, so we can see what we would expect for somebody who has 12 years of education. And we will get, once we calculate that, remember order of operations, you have to take 0.420 multiplied by 12 before you add it to 36.331. And your total here is 41.371, which means we would expect somebody who has 12 years of education to work 41.371 hours in the last week.